Assalamu alaikum respected students. In last video we have discussed about the van der Waal equations. Next problem is also related to the van der Waal equations, especially this numerical is related to the van der Waal constants. We know that in the van der Waal equations A is the constant that's related to the pressure correction, B is the constant that is related to the volume corrections. Here in this question, given the following data, which of the three gases would you expect to have greatest deviation from ideal behavior? Explain why. In this problem, there are the two things at which you must have a strong concept. First of all, you must have a concept about the van der Waal equations, and in the van der Waal equation you must know about the what is the A constant, what is the B constant, and other concept you must to learn ideal gas behavior and deviation from this ideal behavior. Okay, if you have these two major concepts, you would easily clear and solve this problem. First of all, there are the three gases are given: water gas, oxygen gas, and argon gas, and two values of their constants are given. Water gas have a constant 5.54 and B 0.031, and oxygen gas have a value of A constant 1.38 and B constant 0.032. Argon gas 1.38 and B 0.032. We know that van der Waal equation is the modification of general gas equations. Basically, first we learn what is the A and what is the B. A is the related to the pressure correction, and value of A is directly related to the intermolecular forces. If molecules of gas have a stronger force of attraction, value of A will be larger. A larger A means stronger attraction between the molecules, leading to the greatest reduction in pressure compared to the ideal gases law, and increase the deviations. Okay, real gases which have a stronger force of attraction, they deviate more from the ideal gas behavior. Okay, next, I excluded volume, that is the B. A larger B means molecules occupy more space. Increase the effective volume more significantly, which also increase the deviation. In last video we had discussed about the A and B and what is the excluded volume, what is the our effective volume. See this table. Water gas have a value of 5.54, oxygen have a 1.38, and argon gas have a 1.3836. Its mean value of A is larger for water gas. Its mean water have a stronger force of attraction. We already know that water in the form of gas or in the form of liquids, they can have a capacity, they have a tendency to form hydrogen bonding. Okay, hydrogen bonding is the stronger force of attraction. Okay, greatest value for A is for water, and for oxygen and argon about to similar 1.38 and 1.36, and value of B for water gas 0.031, and for oxygen 0.032 and 0.032 for the argon. It's mean for the oxygen and argon, value of A are about to similar and value of B are about to similar. Okay, it's mean their excluded volume, in other words you can say excluded volume of oxygen and argon are same, and excluded volume for the water is slightly less as compared to oxygen and argon, that is 0.031. Okay, with respect to A, water have a larger deviation from the ideal gas behavior. Greater the value of A, greater the deviation from ideal behavior. Less the value of A, less the deviation from ideal behavior. The same concept is related to B. Greater the value of B, greater the excluded volume. It's mean there is greater extent of deviation. Okay, with respect to A, water gas more deviated. With respect to B, oxygen and argon have a slightly larger deviation as compared to water. Okay, I have explained these concepts in the different steps. Hope so you have clearly understand these concepts related to the A and related to the B. Hope so you have clear and got all the points of this problem.